Hello everyone. I'm happy to be here. This is first time I'm speaking at Data Engineering Summit, and I'm so excited to share my insights from the industries. So let me start with my introduction. As you know, my name is Brij Pandey, and I work as a principal engineer at ADP. And apart from this, I'm also a time tech influencer on LinkedIn. So you may want to follow me over LinkedIn for more insights. Now, coming to today's talk, so basically it is about AI-powered ETL pipeline orchestration, where we are going to see how we can use multi-agent system in the era of generative AI. So let's move to our agenda. So our agenda will be like this. We are first going to look into the ETL. So we are going to have a quick recap of our ETL process. Then we are going to see the early ETL with cron jobs, all those basic information and limitations. Then we are going to jump into Apache Airflow because this has been a de facto tool in the ETL side for a very long time. And then slowly we are going to move into generative AI integration. And after this, we are going to look into agentic DAGs in the Airflow. And then we are going to see an alternative of this Airflow, which is an open source thing over here that is called LangGraph. It's not specifically for ETL orchestration, but we are going to see how we can leverage this for the ETL orchestration. And then we are going to look into some of the challenges and future of ETL. All right. So before I start, I would like to give a disclaimer. So basically, I'm not affiliated with any company as such, like Airflow or LangGraph, basically. Okay. So let's move to our first slide. So what is ETL process? So as you know, like I'm not going to explain this in detail. So ETL, as you know, like it stands for extract, transform, load, and it is an essential workflow for moving and processing data within organizations. And it is vital for consolidating data from multiple sources for analysis or for some other purpose too. So now let's take an example of an ETL process. So this is how an ETL looks like. So this is an example of a typical ETL process. So basically we have different source systems, data is coming from different sources, and then we are extracting them, and then we are doing the transformation, means we are cleansing the data, we are massaging the data, we are making this data available in the desired format, and this goes to our data warehouse, which is a highly structured store basically for the data. And from here we can leverage this data as we want. Okay, now there is another term called ELT process. So this is like first we extract the data, we just dump this data. It can be like in a data lake or somewhere. So I think this diagram may not be appropriate. This data, I think there should be data lake or something like that. So we just dump that data and we transform as we need. So this is an example of ELT process, and then there is a reverse ETL, which like where we get the data for our like our day-to-day operation or for CRM integration, etc. So that is called reverse ETL. We are going to focus into orchestration part, so we are not going into much detail of ETL. Although I would like to say that like here is the thing where orchestration comes into place, and that is what we are going to look into. Okay, so now moving into the next slide. So initially in olden times, ETL was managed through cron jobs, a unique based tool that schedule script to run at a specific times. If you remember, Like we used to write programs and we used to schedule jobs as a specific time to extract the data from different source system or do something else with the data. Okay, these jobs enabled automation but lacked flexibility, error recovery, and dependency management, which limited their scalability in the complex environments. So there was no proper way, to manage mm, the manage the dependency or for the error recovery, and it was really a pain. So if you remember or if you've seen like this this is how we used to write our cron jobs. So we used to have our Python script, or we used to write our shell scripts, and then we used to keep our scripts like this, and at a scheduled time it would run, extract the data, and do stuffs. But once it is failed, then it was a really complex thing to go and do the tracing, and then uh, do the dependency and all those things. So it was really difficult to manage. So next we move to Airflow. So there are other tools, that are equivalent to Airflow, but today we are focused on the Airflow. So this is a typical Airflow architecture. So basically we have a scheduler over here, and we have a DAG, which is um, like nothing but directed acyclic graphs for our different tasks. And using Airflow, we can manage dependency, we can manage those error handlings, and we can do a lot more. So this is like UI, scheduler, DAG directory, workers, and then this is a very high level diagram of Airflow architecture. Now, um, if there is an extraction task, like we can say that okay, it connects to data source and pull the data. If there is a transformation task, then they are like, we can say that it applies rule and clean data. So I'm just telling you this just to show an example in our next slides. Then we have loading tasks, so it loads data to the warehouse. Just these are just kind of refresher. Okay, so let's move to our next slide. Um, all right, so now this is how a typical Airflow DAG looks like. So we have we have uh, nodes basically, and these are our tasks over here. So uh, so so we can divide our task like section 1, task 1, section 1, task 2, etc. They work together in a harmony, they do something over there, and then again, like, they can get connected to other tasks, there can be dependency, there can be a lot of other things. And so, but this is how typically it looks like, and this is the code for this one. This is just an example, although in real scenario we deal with much more complex code. So here, like, we have our Airflow DAG library, then we have these Python operators, we created DAG like this one, and then we can create tasks like this. So this is just a basic example of Airflow DAG. So Airflow DAGs allowed uh, for dependency management and complex workflow scheduling, making ETL more robust and scalable. Now, so after the advent of generative AI in 2023, things became really interesting. In all other sectors, people started doing a lot of good things, and Airflow is not an exception. So uh, we can also leverage the power of generative AI in our Airflow workflow, basically. So for example, let's see this one. So this is a typical example how we can leverage this. So if we have a DAG, we have a task, like let's say we have a preparation task, we have a validation task over here. We can inject the prompt engineering in between, and then we can pass that to an LLM, to get the output from that LLM, and then we can pass that output to a quality check basically. And we can do a lot of things over here. This is just an example, okay? We can do a lot of things over here. And so we can use, so for example, when it comes to data cleaning agent, we can use AI models to detect and fill in the missing data based on patterns. We can use LLMs for this purpose. We can also use LLMs uh, for uh, for matching schema changes across data sources automatically. So these are just a few examples, although use cases are huge for this one. And generative AI integrates uh, to automate adaptive transformations, ensuring data quality and efficiency in the real-time workflow. All right, so now let's move to the next slide. Now let's try to understand what is an agent before we go to the next one. So an agent is a computer program that has an intelligence based on underlying AI model. It can act on its own, it can do things on its own, it can it is it is an it is a kind of uh, autonomous program basically, whereas a tool is something which doesn't have any intelligence. It works based on the rules basically, and once its task is done, then it will remain there as a silent uh, entity. But in agent, like, they are more like a live intelligent tool which can act on its own. Okay, so I mean, these are just basic examples, so I'm just giving because we are going to see this in our next slide in action. Okay, so just imagine what if we use a multi-agent system where there are multiple agents working in collaboration and doing certain tasks. They are getting feedback from each other, they are acting based on the feedback from another agent and doing things on their own, right? So just imagine they we can design a specialized expert working on your data. We can have agents for data retrieval, we can have agents for data transformation, we can have agent for data loading, we can have agent for the analysis, and so on. So these are just few examples. These agents can work together, each with a specific role, to extract value from your legacy data, or to just, in data engineering terms, to just do the ETL process. Okay, uh, so now let's see that uh, when it comes to the Airflow, the same principle can be applied over here. We can have agents who are like a specialized worker working on different tasks. And as you can see here in this example, we can create a data mining agent. I mean, sorry, we can create a data mining DAG like this one, which is driven by all these agents. So these are just few examples. So this is for extraction agent. It adapts to source changes, error handling agent, manages retry and alert on failure. These are just an example. So basically, agentic DAGs distribute ETL responsibility among specialized agents, automating complex workflow with minimal human input. All right, so let's move to the next slide. Now, there is a groundbreaking open source library that is called LangChain. You must have heard about LangChain. That is very famous uh, in in the in the landscape of generative AI. Now, LangChain has open source another library called LangGraph. So this is a framework for building a multi-agent system on the principle of DAG. Okay, so here we have a graph, and as you know, like any graph, it works on certain principles. So one is like node, age, and a state. All right, so if we have these three things, we can build a multi-agent system. So this is an example of line graph. So it has a router. A router is a kind of like we can say orchestrator over here, and these are agents. So we have researcher agent, we have call tool agent, we have chart generator agent. So these are nodes. They are acting as an independent agent, but they are collaborating with each other using these edges basically. All right, so this is a typical example of uh, line graph, and let me show you with another example. So as you can see here, we have supervisor. Supervisor is nothing but it is an agent. I'm sorry, supervisor is nothing but this. It is an orchestrator basically. And once we get something from here, like it goes through this, and then we get a callback here, and then the output. So although this is a very simple diagram, and I'm just oversimplifying this, but this is very powerful. So these nodes, like these are nodes, they can act as an agent. We have edges over here, like we have edge, this one. These are again nodes, and the beauty is like we have a state, so we can manage a state of, between these nodes, so that becomes really interesting and powerful. So we have like state, and then we have like age nodes. So using these three, we can build a multi-agent system in no time. So that library is really beautiful, and that can be leveraged for the ETL pipeline orchestration as well. So now this is just an example. This is a detailed example of what we were talking about. So we can have a supervisor over here. Let me just minimize this. Okay, so we can have a supervisor over here, and then these are agents. They are working in collaboration with each other, and this is a kind of orchestration. Okay, so this example is just to query a legacy database, pass the result to an AI for analysis, and then get insight from our legacy data. So as you can see, this is a simple example. So we can import this line graph library. We have a state graph and LangChain. We can import this chat and topic. So this is an LLM model basically. So we can create nodes like this one, as you can see here. So they can be individual independent agents, and then we can add age like this one, like query db analyze, and we can also add this end parameter. So I'm not going into much detail into this one, uh, but this is just an overview of how a typical line graph orchestration pipeline looks like. And then we can invoke this pipeline. So now coming to the line graph for multi-agent orchestration. So we can use we can create multi-agent orchestration for ETL also. We can create an agentic DAG without using Airflow. And as you can see here, we can use this as a supervisor, and this is a DAG. We have different things going on over here, like data extract and so on. So uh, this can be leveraged for orchestrating our ETL pipelines as well. Uh, these are just, typical examples which we have been looking into since the beginning. So extraction agent, error handling agent, and then line graphs multi-agent structure allow ETL systems to evolve beyond a traditional workflow using AI agents for sophisticated autonomous orchestration. Now, what we have discussed so far is like cron jobs. So they are like basic time-based scheduling. Then Airflow is a managed dependencies across tasks. Generative AI, adaptive data cleansing and transformation. Line graph, intelligent agents for real-time scalable ETL. Just do not go on this part. I would just focus on this one: cron jobs, Airflow, generative AI, and line graph. So as we saw how we can leverage line graph to automate ETL pipelines, where like we can use generative AI to do a lot of things which were done using rule-based traditionally. I mean, which were rule-based traditionally, that we can automate. So for example, like if there is a missing data, generative AI can fill it. If there is something else, generative AI can also do that. If there are some errors, it can find the root cause, and it can make sure that our jobs are running smoothly. So we are giving an intelligence to our agents and to our orchestration pipeline. Now, of course, when it comes to any new technology or any new implementation, that is not without challenges. So so in order to build a multi-agent system, we need a lot of things. We need resources, and complexity is also there. Although we can get started quickly, in order to scale that one, we need to have a proper infrastructure, and also integrating that with a legacy tool is difficult. And if there are low latency requirements for real time data, then it can strain resources. All right. And apart from this, of course, like we have things like data privacy and all the ethical things which are going on, and data governance. So that should be there, and we need to take care of that one. In order to take care of all these things, we need a sophisticated system. But the good thing is that it can be built quickly, and it can be like as time passes, like uh, it can be made a sophisticated tool. So yeah, so that's it from our multi-agent ETL orchestration tool using LangChain. Now in future, what we are going to see is we are going to see more predictive capabilities using AI to predict data volumes, adjust resources dynamically in DAG itself. Then we are going to see AI system handling data pipeline errors autonomously. So we have already covered this one. So this can be done easily through agent. And then of course, like we can remove a lot of things which we do at a later stage, like we can do real-time data uh, using these processes. Basically, we can implement this also in real-time data or streaming data. So the future of ETL lies in intelligent, self-managing system that optimize data flows and resource usage autonomously, setting the stage for the next generation of data integration. So thank you, and I hope this was helpful. And things are becoming really interesting. Things are evolving very fast, but this is really interesting to see how people are going to utilize this kind of tools in their ETL pipelines. So I will be available on the chat for any question answer thing over there. Please feel free to ask me any question. Thank you so much. Thanks for your time.
Okay, it looks like our first question came through. Um, are there any plans to make a pull request to Airflow?
Uh, yes, I would say yeah, that can be done, but definitely like we need to think in that direction to make that a pull request. But yeah, I mean that is a very good question. So Just imagine like integrating this with Airflow. It can be a game changer. We'll see how it goes. Like, yeah, but at this time, I haven't seen anybody doing that.
Okay, we have also curious what you think about whether GPT-5 or O1 potentially doing similar things well.
GPT-5 or potentially doing sim. Yes, they would be doing definitely. I mean, why not? I think they can do things, but as of now, like we do not have any answer. But yeah, like I mean, in order to build this kind of orchestration pipeline, if you're talking, we need a specialized agent, and that any LLM based system can do. So it's not limited to GPT-5 or O1. So if I understand your question correctly, you are talking whether they will be able to do everything on its own. Of course, like that can be done, but the thing is that we need to set up everything, you know, separately for a multi-agent system. Otherwise, that will not be a multi-agent system. So if I understand this question correctly, this is my answer. Yeah, thank you so much.
Thank you. Bye.
Bye.